Hello, here I am going to very briefly demonstrate about a CI/CD architecture for deploying a sample WordPress website to a EKS cluster in production. As you can see in this picture, the local WordPress environment is running on Docker setup, and we will deploy this WordPress application to the EKS cluster through a Jenkins distributed build setup. Here the Jenkins is configured in a master-slave setup and builds are happening in the slave for demonstration. In the production side, we have a EKS cluster with 2 nodes for example, and we have also configured horizontal port autoscaler. We have also configured an ALB ingress controller and a node port service for creating an application load balancer for exposing the application. The application load balancer is integrated with the SSL certificate from the AWS Certificate Manager for an example domain registered in the Route 53 itself. And finally, for the cluster monitoring purposes, we have configured the Kubernetes dashboard and also the Prometheus and Grafana setup. So in a very high level, I will show each stages of this CI/CD workflow. So this is the EC2 dashboard, and we have here 2 instances for the clusters, and one is I have configured as an unmanaged node and another one as managed node for an example. And we have our developer machine. Developer machine is also configured as an EC2 instance for demonstration, and the other 2 instances are for Jenkins. One as Jenkins master and another one is as Jenkins slave. And here this is our local developer machine. Here we have set up our Docker and hosted the WordPress application. So you can see here we have Docker container running, 2 containers running, one for the WordPress application and another one for the MySQL backend. And this is exposed in port 8081, and we can see that here that is a developer machines. We can see the public API, and here it is already in 8081. This is the local WordPress running in the Docker container. Here this is just one of my sample website for demonstration purpose. Only few pages are there just for demonstration purpose. And for the local WordPress environment, we are using for volumes, we are using EFS. So it is mounted here. You can see that we are using EFS for the WordPress volume. We have created a file system in a EFS. This is mounted in the local machine for the local WordPress volume. This WordPress environment is also connected to a GitHub repository, so that after making changes, it can be pushed to the GitHub repository for further build steps. This is a GitHub repository to which our local WordPress environment is connected. As we have mentioned earlier, we have our Jenkins configured as a master and slave. So you can see you have already saw 2 instances for Jenkins. One is for master and one is for slave. And this is the Jenkins application that is running in port 8080, and you can see one job here. This is our build job, and this build is configured so that in such a way that the build is actually happening in the slave. You can see here these are the different stages of our build pipeline. We can see the last build in console, so that you can see that this is running on the slave machine. So this is our Jenkins architecture. So after making any changes in the local WordPress environment, we will push that to our GitHub repository using a script here, that is the push changes script. And once this script is executed, the updated files are getting pushed to our GitHub repository. And Jenkins will know that by using a webhook configured in our repository. That is, a webhook is configured. You can see that in the webhooks. There is a webhook configured, and through this webhook, the Jenkins will know that there is some changes happened in our repository, GitHub repository, and automatically the build will start. So this is our EKS cluster. This is the EKS cluster, and after the build stage, that is the build happens in the Jenkins. We have already mentioned that after the build stage, the new image is getting pushed to the ECR first. This is the stage for pushing to ECR, and from the new images get deployed to our EKS cluster. So now regarding the EKS cluster, we can open one more tab here. One more tab I have opened in the developer machine. So you can see we have 2 nodes in our cluster, and we can see the ports in our namespace. Our namespace is WPFS, that is where our application is running. we can see there are two ports currently running in our namespace, that is WPEFS namespace. One is for WordPress and another one is for the MySQL, and we can check the ports in our cube system. In cube system you can see a number of ports, and apart from the default ones, one I want to mention mainly are one is the ALB ingress controller port, that is for the creating the application load balancer and related resources, and next one is this is the cluster auto scaler. This is also running, that is for the horizontal auto scaling of ports, and then the CSI controllers, you can see corresponding ports, and then next one is the metric server, that is to collect the metrics from the EKS cluster. So the next I want to mention is about the load balancer. I can just open that in another window. The load balancers, you can see here there are three load balancers. One is for Prometheus, one is for Grafana, and another one is our application main load balancer for exposing the application. This is the one that is created using the ingress controller resource. Okay, and this one you can see among the listeners there are two ports. Listeners are for two ports. One is regular AT and another one is HTTPS. And here the certificate, we have obtained the certificate from the ACM itself, from the Amazon Certificate Manager. For this demonstration purpose, I have already registered a sample domain, that is the embearclasses.click. In the click domain, I have registered a domain name, and issued a certificate, and got a certificate from the Amazon Certificate Manager itself. You can see that here, and I have used this certificate in the HTTPS listener here in the load balancer. We can configure that at the time of creating the ingress resource. So the next thing I want to show is regarding the Kubernetes dashboard, but before that, as we have already running the metric server here, we can get the metrics from command line itself using the kubectl command. Kubectl, we can use the top command, top ports, and we can get it from our namespace now. You can see the resource usage of our two ports running in the WPFS, our namespace, and we can try getting it from the cube system. Okay, so these are the resources used by the ports in the cube system namespace. So the next, for getting the Kubernetes dashboard, I am running the kube proxy from my local machine itself, because I am taking that from my browser in my local machine. Okay, and for token, I have to paste the token here, and you have to change the namespace here. We can check in the WPFS namespace first. Yes, you can see all the information here, the running deployments, number of ports, replica sites, etc., etc. You can see from here itself. And the left side, we can categorize different components. We can check the deployments. There are two deployments. One is the WordPress and the backend MySQL, and then in the WPFS namespace we have one ingress controller, and you can see that this endpoint, this is the endpoint of this load balancer, and the same is associated with our domain name. And so there are a lot of configurations you can see from this Kubernetes dashboard in a very beautiful and convenient way, rather than checking it from the command line. And if we can check the things from the cube system, I'll just select the cube system namespace and see the workloads. So there are 6 deployments in the cube system, 17 ports running. You can see the deployments here. This ALB ingress controller, this all comes under this cube system namespace, default namespace, and cluster autoscaler. Yes, this cluster autoscaler is we have already configured at the time after deploying this Kubernetes cluster, so we can try autoscaling our deployments in the WPFS namespace. I will show you that in a few seconds. So let's go back to the WPFS namespace, and now we can see that there are 2 ports running. We can once again confirm that from the command line also. So kubectl get ports -n WPFS, you can see that there are 2 ports. We have already saw that. So rather than autoscale that from the command line itself, it is very easy to do that scaling from the Kubernetes dashboard itself. So now you can see that WordPress has 1 port running, and so we can try scaling from here itself. You can see an option here for scaling. So the actual replica you can see is 1, and desired replica we can increase that to 2. They will also show a equivalent command line so that we can execute that from the command line if we want. Now we can try to increase that to 2 and just click the scale button. You can see that now it's in the pending state. Just give some seconds for this to complete. Yeah, so it's now showing that now the number of ports has increased to 3. So it's very easy. Once autoscaler is enabled, the number of ports can be increased or decreased, depends upon our need, and it will also do that according to the load it gets. Okay, so just check that from the command line also once again. Yeah, now it's increased. The WordPress ports number is increased to 2 now. You can see that 2 ports are running here. Okay, so that's it. So it's very convenient to use the Kubernetes dashboard. So just there are a lot of functions, lot of components here you can configure from the dashboard itself. I have just shown only one of the most important thing, that is the auto scaling. As we have implemented that, it's one of the most convenient and easiest method for scaling the ports. So we can just scale down to 1 itself. So it will take some time to terminate the one instance and scale down to 1 itself. We can just it will be yeah, it's already gone. Now it's only 1 port for the WordPress instance. Okay, so it's working perfectly. Yeah, it's here also it's updated the status. So that's all about a brief idea about the Kubernetes dashboard. Next we can see how the Prometheus and Grafana is working. So next for the Prometheus and Grafana, we can see that we have our load balancers for these 2 services. That this is Prometheus and for Grafana, and we can access that from the load balancer endpoint URLs from the DNS name itself, and we can see the listener. The Prometheus is running in 1990 and Grafana from port 80 itself, and before that I will show you the ports, corresponding ports running, and we can verify that both the Prometheus and the Grafana are installed. You can see that we have our namespace named Prometheus, in which we have installed our Prometheus and Grafana using Helm chart, and we can get the ports. Yes, you can see the ports corresponding to this. This is a Grafana, and for this Prometheus, you can see that these are running now. And we can just see the services also, the corresponding services also. Yes, now you can see that there are 2 external IPs, that is a load balancer URLs. That is one for this Grafana, that is we can access this from here, this URL. That is the same we saw in the load balancer. This is exposed in the port 80 itself, and the Prometheus, that is the Prometheus, this one, it is exposed in this URL with the listening in the port 9090. So we can just copy this URL and try pasting in the browser for seeing the Prometheus. Yes, so this is the Prometheus. We have not configured any graphs yet. The idea is just to show that this is installed and it's available in the browser. Okay, and the next one is Grafana. We can try the Grafana also in the browser. That is listening in the port 80 itself. Yes, this is the Grafana UI, and we have not here also we have not configured any dashboards yet. We can just quickly load from some default UIDs, and we can load. Okay, and data source, of course we have to select the Prometheus, because from that Prometheus this Grafana is getting its data, and we can click the import. This is just to get some quick dashboards. Yes, so we can configure and dashboards the way we want. This is just a demo, so I have not configured any, customized any dashboard set. We can see all the informations here, the memory usage of all the ports. We can see all the informations, and the beautiful thing is that we can create a dashboards like the way we want. Okay, we can add panel, we can add new rows, everything is customizable here. So that is a brief idea about this Prometheus and Grafana. So we have installed, and it's running fine in our setup. So next we can see the working of the CICD pipeline. So this is the WordPress website that is running in the local environment. We have already seen this is listening in the port 8081, and I will show you the production site. This is the one, that is the ember classes.click. Actually, this is a sample website I have deployed in the AKS cluster for this demonstration purpose. And the domain, this domain, as I have mentioned earlier, this is purchased from the Amazon itself, ember classes.click. So what we can do is I will just create some new blocks in this WordPress, and I will show you how this get deployed to the production side using the CICD pipeline. So first we can log into the WordPress admin just for this demonstration purpose. Okay, and I will create a new post here. Okay, and I am publishing this now. Okay, and I am signing out from this admin panel now, and we can see whether this post is published in the local environment. We can just click on any post, and okay, this is a new post that is listed here in the right side. Google Pixel 7, just we have created now. Yeah, this is a new post. We have created this now, and this is available in the local environment now. We can check whether this is deployed to the production side. This is the production side site, ember classes.click. You can also available this site from your browser. Okay, and we can see that this new post is not yet deployed to the production side. Okay. So for initiating the CI/CD pipeline, what we have to do is from the command line, that is from the developer machine. Okay, we can switch to sudo, and we can give it to the okay, and this is the WordPress environment in the developer system. And after making any changes, we can just push those changes to the GitHub with using this script, push changes.sh. I am running this script now. Okay, the script is pushed, and we can take the Jenkins, and we can see that this pipeline will now get triggered automatically using the GitHub webhooks. It's getting started. Okay, this is the build number 148, that is the latest, that is started now. Just we can wait for a few seconds, and actually I have given a option here for in the Jenkins. You can see that I have given a this approval stage. I have just given a approval stage here, and it will ask for in this stage. From when it reaches the deploy to prod stage, it will ask whether we want to proceed or not. So whoever they have an access to the admin access to the Jenkins, they can select this whether to proceed to the next level or not. So I am just if you want, I can avoid this stage where this question, then if I avoid this question, it will get deployed automatically. I am pressing the proceed button here so that the rest of the stages will complete automatically. So I have given to proceed, and this final sync is the last stage, and so the build is complete now. And we can see from the console output, we can verify that the build is happened on the slave machine and not in the master. That's how we have configured this. Now we can once again check the production site and go to the home, and we can refresh the site. Once again we can see this new blog is updated in the production level site also. That is this Google Pixel 7 review post. It is automatically updated in the production level site also. This site is actually running in the EKS cluster. Okay, now we can just check one more thing. We can actually log into the local WordPress environment admin panel and try installing some plugins also, just to check whether that will also get updated in the production level site in the plugins. Just for testing purposes, I am installing this Gutenberg plugin. Before that, I will show you in the production level. I can show and verify that in the production level site now that plugin is not here, so that you will know that it is getting updated from the local environment after the CICD pipeline. In the plugins, installer plugins list, you can see that Gutenberg plugin is not here yet. Okay, So we can just log out, and from the production from the local environment WordPress, that is the one that is running in the 8081 port, I am installing this Gutenberg plugin now. Okay, I am installing this now. Okay, so this plugin is installed now, and I am activating it. Okay, so from the install list of plugins, you can see that this Gutenberg is here. Now we have made some changes in the local environment. I am again pushing those changes to the GitHub, and correspondingly, okay, those changes are updated in the GitHub, and correspondingly, the Jenkins will trigger the build. Yeah, it's in the pending state now. It will start soon. Yeah, it started now. That is the build number 149. And before deploying to the prod, it will ask whether we can proceed or not. If you want, we can remove that approval stage. After pushing to easier, it will ask whether we can proceed or not. I am giving to approval for proceeding, and after that it will deploy to Kubernetes EKS cluster, and after the final sync, yeah, final sync is also over. Now we can check the production level site and check whether that plugin has updated in the production also. From the list of installed plugins, we can check. Yes, see, this plugin also get updated in the production level site once after the CICD pipeline get executed. So this is a complete setup of the CICD of the WordPress environment that which is running in the local environment is getting deployed to the Amazon EKS cluster. And as we have mentioned earlier, we have our SSL certificate from the Amazon Certificate Manager store itself for the domain purchase from Amazon, and it is integrated in the application load balancer. And we have, for monitoring, we have our Kubernetes dashboard and Grafana and Prometheus. And the build is happening by using the Jenkins in a distributed build environment, and the Jenkins will detect these changes in the GitHub using the webhook event configured in the GitHub. And for the persistence volumes, we have used the Amazon EFS. Okay, so this is a brief idea of the whole pipeline. If you are interested in setting up of any of these type of CICD pipelines in your organization, you can freely contact us. Thank you.